Out beyond the familiar reaches of our solar system lies an expanse of stars, silent beacons lighting the vast cosmic ocean. Each star could harbor planets, some unknown, some familiar, but all waiting for us to find them. These distant, alien worlds exist in a realm so far removed from our own, yet they share a cosmic connection with Earth. Could one of them hold the key to understanding the very origins of our solar system? Could there be a world out there, perhaps a mirror image of Earth, or something entirely different, waiting for us to discover its secrets? For centuries, we have gazed at the night sky, dreaming of distant worlds. And now, thanks to incredible advances in technology, we no longer have to just dream. We can reach out and touch the stars, not physically, but through the power of telescopes and space probes that reveal more about the universe than we ever thought possible. The search for alien worlds has shifted from science fiction to science fact. But even as we uncover more and more, we must remember that what we've learned so far is just the beginning. The discovery of exoplanets, planets orbiting stars other than our Sun, has fundamentally transformed our understanding of the universe. When the first exoplanet was confirmed in 1992, it was like finding the first piece of a cosmic puzzle, yet it was only the beginning. Over the past few decades, the explosion of exoplanet discoveries has completely reshaped our view of the cosmos. Thousands of exoplanets have been cataloged, with more being found every single day. And in many cases, these planets exist in ways we never imagined. Take, for example, the famous Kepler 186f, an exoplanet located in the habitable zone of its star. This planet, just 500 light-years away, has been called Earth's cousin because it might have the conditions necessary for liquid water. Imagine a planet, not too different from our own, floating out there in the dark. It's a tantalizing thought. Could there be life on such a world? Are we truly alone in the universe? Or could life be more common than we think? But it's not just Earth-like planets that have captivated scientists. The variety of planets we've discovered is nothing short of staggering. Gas giants bigger than Jupiter, rocky planets as small as Mars, and super-Earths, planets several times the size of Earth, are just a few of the extraordinary worlds we've identified. With every new discovery, the diversity of planets challenges our understanding of planetary formation, weather, and the very nature of what it means to be a planet. Perhaps one of the most compelling questions in modern science is whether we are alone in the universe. Are there planets out there, circling distant stars, that might have the conditions necessary for life? This search for habitable worlds drives much of our exploration. Scientists are looking for what we call the Goldilocks zone, the region around a star where the temperature is just right for liquid water to exist on a planet's surface. But even beyond this, we are rethinking what it means for a planet to be habitable. Could life exist under conditions that are vastly different from our own? Imagine a planet where the air is thick with methane, or where the oceans are made not of water, but of something else entirely, perhaps ammonia, or even a different solvent we've never encountered. Could life on these planets be as alien as the world itself? We don't know the answers yet, but the question drives us forward. Take Proxima b, for example. Located just 4 light-years away, Proxima b is tantalizingly close to the habitable zone of its star. It might have the conditions to support life, or it might be a frozen world, cold and inhospitable. But we won't know for sure until we take a deeper look. It is worlds like Proxima b that fuel our imagination and keep us questioning. Could this be where humanity's search for extraterrestrial life finally comes to fruition? But the universe is not made up of only Earth-like planets. The cosmos is filled with alien worlds that challenge everything we thought we knew about planets. There are the super-Earths, planets that are larger than Earth but smaller than gas giants like Neptune. These worlds could be rocky or have thick atmospheres that trap heat, making them incredibly different from our home planet. The potential for life on super-Earths is still a mystery, but their sheer size and variety make them key targets in the search for alien worlds. And then there are the gas giants, massive planets made mostly of hydrogen and helium. These behemoths, like Jupiter and Saturn, have immense gravity, and their atmospheres are filled with swirling storms and extreme weather. While it may seem impossible for life to thrive on a gas giant itself, their moons could be another story. Worlds like Europa and Titan, moons of Jupiter and Saturn, respectively, have the potential to harbor liquid water beneath their icy crusts. These moons are some of the most exciting places to look for alien life. In some ways, these gas giants and super-Earths are the giants of the universe, planets that are so different from our own, yet hold the potential to unlock the mysteries of planetary systems beyond our wildest imaginations. They may not be Earth-like in the way we envision, but they hold keys to the universe's diversity and the processes that shape planets. But not all alien worlds are inviting. Some, like hot Jupiters, are extreme in every sense. These gas giants orbit their stars so closely that their surfaces are burned by scorching heat. These planets can reach temperatures hotter than the surface of most stars, creating violent storm systems and volatile environments. Yet, even these inhospitable worlds have taught us valuable lessons about planetary systems, their formation, and how the forces of gravity and heat can shape a world. On the other end of the spectrum, we find ice giants, worlds like Neptune and Uranus, planets that exist in the colder reaches of their star systems. Their atmospheres are filled with methane and ammonia, and they have a mysterious composition that scientists are still trying to fully understand. Ice giants might not be the most inviting environments for life as we know it, but they are crucial to understanding the formation of planetary systems and the role that gas and ice play in the evolution of distant worlds. These extreme environments may seem inhospitable, but they are just as important to our exploration. The study of these worlds expands our understanding of what is possible in the universe and forces us to rethink our assumptions about life and habitability. One of the most fascinating aspects of studying alien worlds is the potential for discovering truly alien forms of life. Life that does not conform to the models we have on Earth. What if life on another world does not require oxygen, but instead thrives in a nitrogen-rich atmosphere? What if, instead of water, it depends on liquid methane or sulfuric acid? The possibilities are mind-boggling. This is where our imagination as well as our scientific knowledge must expand. Life could exist in ways we can't predict, under conditions that would seem impossible on Earth. In the coming years, as our telescopes become more sophisticated, we will begin to analyze the atmospheres of distant exoplanets for signs of life, whether through chemical markers or perhaps even more direct evidence, such as the discovery of biosignatures. We may not yet understand how life could arise in such strange environments, but the search for alien life is also the search for answers about our own existence. Could life, in its many forms, be common in the universe? Or is Earth truly unique in its ability to sustain life? These questions drive us forward. The universe is vast, and every new discovery brings us closer to answering some of the greatest questions humankind has ever asked. The alien worlds we've discovered so far are only the tip of the iceberg. With new technology on the horizon, like the James Webb Space Telescope, we are poised to see further into the universe than ever before. We will look for the chemical fingerprints of life, study the atmospheres of distant exoplanets, and perhaps even send spacecraft to explore distant moons and planets.